What Busu do right now? Let me test her with coding method.
Oh no, I cannot read the message.
Don't worry, Busu. Let us help you.
Assalamualaikum, my name is Rushaida Imam Miruzani, and I will help Busu to find the secret message sent by Along by using matrix K1. So here is the matrix K1 given. We need to find its inverse by using adjoint method. The formula to find inverse by using adjoint method is inverse of K1 is equal to 1 over determinant of K1 multiplied by adjoint K1. So let's solve this step by step by finding the determinant of K1 first. So I choose row 2 to expand the row 2 from matrix K1 to expand as it contains 0 here to make my calculation become easier. So as a result, I got this equation, which makes me needed to expand it again. And as I expand this one by one, I got for 1 I got 7, for 2 I got 7, and for 3 I got 14. And as a result, I substitute the values into this equation, which is -4 multiplied by 7 plus 2 multiplied by 7 plus 4 times 14 is equal to 42. Hence, determinant of K1 is equal to 42. Finish finding the determinant of K1. We find the adjoint of K1 by finding the cofactor first. So I find the cofactor step by step. For row 1 column 1 I got 30. For row 2 column 2 is equal to -60. Row 1 column 3 I got 18. Row 1 column 4 equal to 0. Row 2 column 1 I got -7. Row 2 column 2 is equal to 7. Row 2 column 3 is equal to -7. Row 2 column 4 is equal to 14. Row 3 column 1 is equal to -14. Row 3 column 2 is equal to 56. Row 3 column 3 is equal to -14. Row 3 column 4 is equal to -14. Row 4 column 1 is equal to -10. Row 4 column 2 is equal to -8. Row 4 column 3 is equal to 8. Row 4 column 4 is equal to 14. So finish find the cofactor. We need to transpose it to get the adjoint of K1, which is 30, -60, 18, 0, -7, 7, -7, 14, -14, 56, -14, -14, -10, -10, 8, and 14. However, this is not the inverse, so we need to substitute this adjoint into the formula given above, which is inverse of K1 is equal to 1 over 42 multiplied by adjoint of K1. So the result from this equation, we got this type of inverse and multiply it by matrix P. Multiply it by matrix P with inverse K1 in order to get secret message. However, this set of matrix will not match with any coding method given. Hence, matrix K1 is not the key that can describe the secret message sent by Along. So let's try out matrix K2, which will be explained by Shafiqah. Thank you.
So, Assalamualaikum and hi, my name is Nur Shafiqah. So let's see the K2 matrix. Okay, this is the K2 matrix. So I have to inverse it by using ERO and determine whether this inverse can decrypt the message. So let's go to ERO. Okay, so first thing first, I have to write the matrix in appropriate notation before inverse it. So I will write it like this. Okay, jump to the next steps. I will multiply row 2, this row 2 by -5. So, and I will add it to row 1. So, this will result in -22, -21, -44, 0, 1, -5, 0, 0. The second step, I will multiply row 2 by -5 and I will add it to row 3. So I will get negative 24, negative 21, negative 44, 0, 0, negative 5, 1, 0. Next, I will multiply this row 2, okay, I mean this row 2, I will multiply by negative 9, and then I will add it to row 4. So then I will get negative 36, negative 34, negative 72, 0, 0, negative 9, 0, 1. Next, I will multiply row 1, okay? This row 1 by negative 1. I will multiply row 1 by negative 1, then no more negative sign, then it will become 22, 21, 44, 0, negative 1, 5, 0, 0. Then I will divide row 3 by negative 3. Then we look at this negative, row 3. This row 3, I will divide it by negative 3. Then I will get 8, 7, 16, 0, 0, 5 over 3, negative 1 over 3, and 0. Next step, I will divide row 4, this row 4 by negative 2. Then I will get 18, 17, 36, 0, 0, 6 over 2, 0, negative 1 over 2. Okay. Then I will multiply row 3, this row 3, which is 8, 7, 16, 0, 0, 5 over 3, negative 1 over 3, 0. I will multiply by negative 3. Then I will add it to row 1. This row 1, then I will get negative 2, 0, negative 4, 0, negative 1, 0, 1, 0. Then I will multiply this row 3 by negative 5 over 7, and I will add it to row 2. Then I will get negative 5 over 7, 0, negative 10 over 7, 1, 0, negative 4 over 21, 5 over 21, and 0. Then for row 3, I will multiply row 3, this row 3, by negative 7 over 7, and I will add it to row 4, and I will get negative 10 over 7, 0, negative 20 over 7, 0, 0, negative, 19 over 42, 17 over 21, negative 1 over 2. Then I will divide this row 1 by negative 2, okay, I will divide them, and I will get 1, okay, this one, I will divide this one, then I will get 1, 0, 2, 0, 1 over 2, 0, negative 1 over 2, 0. Okay, we're coming to the end. Okay, then this row 1, I will multiply by 5 over 7. Then I will add it to row 2. I will get 0, 0, 0, 1, 5 over 14, negative 4 over 21, negative 5 over 42, then 0. Okay, we're coming to the end. Then I will multiply this row 1 by negative 8, and I will add it to row 3. I will get 0, 7, 0, 0, negative 4, 5 over 3, 11 over 3, 0. Then I will multiply row 1, okay, row 1 by 10 over 7, and I will add it to row 4, okay, the last row. So I will get 0, 0, 0, 0, 5 over 7, 19 over 42, 2 over 21, negative 1 over 2. Okay, then this row 3, I will divide it by 7 because we have this 7. So I will get 0, 1, 0, 0 for the left half, and the right half I will get negative 4 over 7, 5 over 21, 11 over 21, and 0. As we can see, the left half, we cannot transform them into identity matrix. Then this means that the inverse does not exist. Since the inverse does not exist, we cannot decrypt the message.
Hi, I'm Susanna. So I'm going to explain how I solve the inverse of K3 using elementary row operation to find the hidden message. So the first step is to form the augmented matrix. We copy matrix K3 to the left-hand side and identity matrix at the right-hand side. The next step, we need to perform elementary row operation until we get the identity matrix at the left-hand side. So in order to perform ARO, we need to multiply row 1 with 1 over 3. And then row 2 will be minus with 2 multiplied with each element in row 1. Okay, and then row 3 will be minus with 4 multiplied with each element in row 1, and the same goes for row 4. We will minus row 4 with 2 multiplied by each element in row 1. The next step, we need to multiply row 2 with 3 over 11. Then we need to add 2 over 5 multiplied by each element in row 3 to row 1. So after obtaining the value for row 1, we need to add 5 over 3 multiplied by each element in row 2 to row 3. The next step, we need to subtract 8 over 3 multiplied with each element in row 2 from row 4. Then multiply row 3 with 11 over 6. So then we will minus row 1 with 2 over 5 multiplied by each element in row 3. And then add 14 over 11 multiplied by each element in row 3 to row 4. And then after obtaining the answer, we will multiply row 4 with 1 over 3. And then subtract row 4 from R1. It means each element in row 4 will be minus with each element in row 1. So here we can conclude that there is an inverse as it is a non-singular matrix, and there is identity matrix at the left-hand side. So hence, the inverse of K3 is as stated here. So we will multiply matrix P with the inverse of matrix K3 to decrypt the secret message. So here the secret message is Malaysia Prihatin. So that's all from me. Thank you.
Let me try it first. Yay! I can read the message. Thank you, guys.